just start with the general overview in machine learning, and then I will go through some clinical project that I'm doing during this time. Machine learning is a subfield of computer science, and it gives computer ability to learn. Actually, something going wrong here. Sorry. It explored the study and construction of algorithms that can learn from data and make prediction on data. It is used to reproduce known pattern and knowledge automatically apply to the other data. So this is an overview of what we really do in machine learning. We have some input terms and we have some output terms, and we have machine learning algorithm in between. So usually in the different community, we use different type of term as an input. For example, features, attributes, predictors, independent variable. All these terms have got the same meaning. And we use this one as an input of the what type of machine learning algorithm we use. It depends. And there are different models and techniques. And for the output of the terms, if we have a outcome to predict, we can call this like a class, target, dependent variable, or response. So all these output terms also have the same meaning. So type of problem and task in the machine learning, we categorize in different categories. So supervised learning, the computer is presented with example input and the desired output. The goal is to learn a general rules that maps input to the output. And this is very common in different type of clinical scenario that we are working. So we know, for example, what target do we want to predict. Unsupervised learning, no label are given to the algorithm. We don't have no outcome for our data, and we have to find the hidden pattern in the data and make a prediction. Reinforcement learning is also another area in machine learning. A computer program interacts with a dynamic environment, and the program is provided feedback in terms of reward and punishment, and it is investigated the problem space. So we have to interact with the dynamic environment. So machine learning prediction model, for example, for classification supervised machine learning, there are some famous model like a decision tree, boosting, bagging, logistic regression, neural network, and deep learning. Neural network and deep learning are hot topic these days. I think everybody heard that. And also we have a regression type problem, like a multiple linear regression, k-nearest neighbor regression. So the outcome of our prediction model is the continuous data. And then we have a clustering or unsupervised method and problem, like a k-means clustering and other clustering method. So, you know, there are different type of challenges in machine learning. One of the challenge when we work, for example, in genetic data or large number of data is dimensionality reduction. So dimensionality reduction, we classify in two different types, like a feature or variable extraction. So we do some transformation without reference to the output by exploiting the dependency between the output feature. I think if there is a principal component analysis or principal component regression, there are some very famous methods in dimensionality reduction for feature extraction. And then we have a feature selection method to find a subset of the original variable that enable more accurate prediction by elimination of irrelevant and confusing the information. Some of these features that we are trying to do the prediction are not necessary in task of the prediction, and they are like a noise. So we have to remove this feature by feature selection method. So here there is another thing in machine learning, like a training and testing. There are different methods to train the ML method and test the ML method. So, for example, percentage split is one of the popular one. You take the 70% of the data for training and 30% for testing. We usually take more data for training because our algorithm should see more data to learn how it should behave in different type of challenges. And there are bootstrap method is random sampling with replacement, and cross-validation is one of the popular method these days. So as you see in this figure, when we have the original data, we randomly select the data and divide it to different portions. So for example, here we have 5-fold cross-validation. In fold 1, if you see fold 1, we take 4-fold for training and 1-fold for testing. In the fold 2, we swap the training and testing randomly again. We again take the 4-fold for training and 1-fold for testing, and we carry out this procedure. And then we compute the performance of the machine learning algorithm based on this test fold. So it was just some general introduction about the machine learning. If you want to know more, you can ask questions later. And also I recommend this book. So Pattern Recognition and Machine Learning with Christoph Bishop is a very excellent book for learning the classification and regression model. So let's start with some clinical project that I am doing with machine learning. So we have some preventative strategy method. So I was working in the project with collaboration with Arthritis Research UK. We try to predict psoriatic arthritis in patients with psoriasis. The other project I was working, it was the use of machine learning method for mapping the acoustic measurement to more GRBAS score. I will go to detail of this project in next slide. And the final is precision medicine. So prevention strategy, what does it mean? We need to identify the individual that are at high risk of developing a disease. So many clinical scenarios would benefit. So if we try to identify the individual that are in high risk of developing a disease, we can prevent disability, morbidity, and some other type of the disease. For example, psoriasis is an autoimmune disease. 30% of patients with psoriasis develop a psoriatic arthritis. So patients with psoriasis, they are in high risk group. So when a patient with psoriasis go to doctor usually don't care if this patient develops psoriatic arthritis in the future. So if we develop a prediction model that can tell the doctor what is the chance of developing, for example, psoriatic arthritis for this patient, it would be very useful information because doctor can start the treatment earlier and can prevent the chance of disability for this patient. So the research pipeline is very, again, general overview from what we were doing. So we had our database from psoriasis and psoriatic patients, and we try to do some data processing. When we get this clinical data, we have to do a lot of cleaning because we have a lot of missing value from the patients. And then we have to do some confounding mitigation. Maybe you can get familiar with these terms in literature, like a confounding, and we do feature selection and model development. So feature selection, we want to identify the informative predictor for differentiating psoriasis arthritis from psoriasis. And this task is like a supervised learning because we want to predict psoriasis arthritis. So this is an example of from the database. If you see here in status, we have 0 and 1. This is like a supervised type learning problem. So the patient who have a psoriatic arthritis, we label this as a 1. Actually, the clinician label this with 1, and 0 is the patient who has psoriasis. And here in this column, we see some features. For example, if in some of you have a biology background, this is from HLA region. So we were working MHC region, and in genetic we have large number of features or variable, and some of them, as I mentioned, like a noise, and they are not important in task of prediction. So we have to identify the most informative one. And this 3 is like a confounding variable. You can get familiar with these terms if you want in the literature. So in this task, we want to predict psoriatic arthritis. Identify what are the informative features. So there are different type of feature selection in literature, like a filter method, wrapper method. Some of the feature selection techniques, they are independent of the prediction model. For example, I mentioned some type of prediction model like a boosting and random forest. Before I use any type of prediction model, I try to remove some of the irrelevant feature by filter method and take the irrelevant feature to the prediction algorithm. Here, for example, in a stage of model development, we take the 80% of the data for training and 20% of the data for whole lot. And we do some nested cross-validation, hyper-power tuning, and we compute the performance of our model. So we internally validate this model, and we see what performance do we get. And then we interested to see how reliable is this method if we want to use in different hospitals around the world. Because if someone wants to predict the psoriatic arthritis in another hospital, we should really see how we can rely to this method. So in UK, we have access to different biobank. So the training I was doing for my machine learning, I had access to some data from local hospital, and to externally validate my models, I try to use biobank data. So see how this data and model work in the external validation part. This is, for example, some results I'm showing here. But again, I say, if you want to know more technical, you can ask me question later. Here, XGBoost is one of the famous machine learning algorithm these days. And we try to do some feature selection. If you see in the column, we have different feature selection techniques. And we decided to select different number of features. For example, if I give one feature to XGBoost, what performance do I get? So these numbers is area under curve. So there are different metrics you can evaluate the performance of your machine learning algorithm. It would be area under curve, precision, recall, F-score. It depends what is in your community. But area under curve is one of the famous one. And this is random forest. So we were saying, for example, with one feature, the performance we get is about 54%. And if we increase the number of feature, how the algorithm change. So this is for psoriatic arthritis, but it's a lot to say, to be honest. And there is another project I was doing with clinician in Department of Head and Neck Surgery. So your vocal cords can be damaged by speaking or singing too loudly, infection, stroke, polyps, and cysts. This kind of problem can cause loss of voice quality. Therefore, voice quality assessment is required by clinicians. Currently in hospitals, clinicians use a subjective standard scale, which is like a gold standard that called GRBAS. GRBAS stands for grade, roughness, breathness, asthenia, and strain. Grade is overall degree of hoarseness or voice abnormality. Roughness is irregular fluctuation in amplitude and fundamental frequency of voice in source. Breathness is air leakage through insufficient glottal closure. And asthenia is weakness in the voice due to unnatural vocal cord mechanism. Strain is the fourth terms in the GRBAS standard, which is difficulty in initiating and maintaining voice speech. So, for example, when you go to clinics, if the clinician gives to your voice a score 0, it means you have a normal voice. And if they give you a score 3, it means you have a severe voice. So it's very interesting when you see different clinicians, you may get different scores for your voice because this is like a subjective assessment. The advantage of GRBAS is widely recognized and understood by clinicians around the world, but it has 3 main disadvantages. Highly trained human listeners are required, which is expensive. Listening to the patient is a time-consuming process. Inconsistency, as I mentioned, will occur. Clinicians may give different scores for the same voice. So the aim in this project was to design and evaluate objective measurement of voice quality conforming to GRBAS standard with accuracy and consistency that match that of trained clinicians. And we had a hypothesis, computerized measurement of voice properties using digital signal processing was done to assess the subjective GRBAS scores. So here, for example, I developed, because for training for build up the computerized measurement, we had to train the machine learning algorithm. So I developed a tool here to collect the GRBAS score from clinician. So this tool let the clinician to play out voice sample in random order with appropriate repetition. Enables the score to be entered by clinician and recorded in a database. Consistency can be tested for clinician in scoring. So we hired 5 clinicians and we asked them to score different patients, and this project, it took about 1 year to collect the voice data because the patient had to come to clinic and collect their voice. It was really we need to spend a lot of time in this aspect. But for some project like a psoriatic arthritis, because we look at the genetic data, we just take a blood sample, and it's cheaper than this project. For example, we just analyze the 10,000 million of genes or 10,000 patients, we will have more data. So in different clinical scenario, the number of data actually can be different. So this is, for example, the result. We evaluate, this is the computerized measurement technique, like a supervised method, k-nearest neighbor regression. We see how this method, we evaluated against 5 speech and language therapists who scored the patient. And for some of these methods, actually the clinician was doing better. For some of them, the computerized method was doing better. And finally, precision medicine is a hot topic these days, and it's the topic of my fellowship. This is something I'm working on. Precision medicine is the customization and tailoring of medical intervention to the individual, and has the potential to have an impact on the healthcare. Precision medicine offers a path to helping people stay healthier for longer, recover from illness faster, and avoid wastage of the healthcare resources. This potential can be fully realized if we are able to accurately predict the outcome of patient in different clinical scenarios. Prediction model can be constructed using data from clinical record, genetic, and other markers of biological activity. So in precision medicine, we get different type of data and we try to integrate all this together. So our aim is, again, application of machine learning and statistical approaches to integrate different complex data set and find the best approach that maximize predictive performance in different clinical scenario. And we have different challenges actually in precision medicine. For example, if we work in genetic data, there is high level of redundancy. We have to see how we should come up the solution for the high level of redundancy. There is potential for confounding factor. We have large number of features, so we have to do some data pre-processing approach, like a filter feature selection that I mentioned earlier, confounding mitigation, feature extraction, and we integrate different database. In this project, we try to do some treatment response for patients with rheumatoid arthritis. And also there is another project we are working with for patients they have psoriatic arthritis. So these are the end of my presentation. I know I didn't go that much details, but I'm more than happy if you have any question to ask. Thank you.
Thank you, Dr. Jalali. That was very informative. We do have quite a few questions, so we'd like to open up the Q&A. If you do have any questions, please type them in and we'll be happy to answer them. One question that we have here, actually that we're getting in, with the dynamic environment, how do we distinguish what data we are sampling?
And I have not done any project in that, so I'm not sure about this question. I don't know really, to be honest. It's not part of my area, reinforcement learning.
You mentioned feature selection methods. What are those, and do you have any examples?
So filter method, wrapper method. So these are the type of feature selection method. So filter method, for example, one of the simpler example is like a Pearson correlation. So you try to compute the correlation between the dependent variable and the outcome. And for example, if you do individually for each variable, the variable that get the highest correlation, you will see this is the most informative one. So the Pearson correlation is the simplest one we usually do for filter method, but there are some other method like a information theoretic method. Some of the features, they are highly correlated together. So with some mutual information technique, we try to minimize the redundancy between the features and dependency to the target, for example. These are for filter method. And wrapper method, they are classifier dependent method. So for example, you try to look at the different combination of feature based on the predictive model, and you see what performance do you get. For example, if I have the combination of 3 features, what is the performance? If I have a combination of 4 features together, what is the performance do I get? So wrapper and filter, they are the most popular one, and hybrid method, which is the combination of these together.
Great, thank you. Can you explain more about reinforcement learning and what is the idea behind it?
Actually, as I mentioned, reinforcement learning, just like give a general idea about that, but it's not part of my expertise. It's just you get, for example, in some game method or in some robotic method, I see people use the reinforcement learning, but in the clinical project, we usually use supervised and unsupervised method. If they are more interested to know about this, I think they should look at the book I have introduced.
Okay, fair enough. Great. We have some questions about what kind of advice you might have for anyone interested, maybe students interested in perhaps they've done software engineering, they're interested in artificial intelligence, top schools to study at, or any general advice and anything about that?
Sure. So I think for a student, if they want to start machine learning, so they can do degree at university, or before that they can start to do some online courses in Coursera. I don't know. I think everybody is familiar with Coursera. There are different machine learning courses from beginner, intermediate to advanced. So they can, and this course actually run by Stanford University. So they can do some online training and they can attend to the exam. And if you want to get a certificate, they have to pass the exam. But if they just want to listen to the video without a certificate, there is another thing they can try. So I would suggest for somebody who wants to go to the machine learning, maybe they can start the online training and then start to apply for university. I think it's a good thing to do.
Good. We have a question about, is it possible to use AI on fetus genes to predict possibility of sickness in them before they're born?
Sorry, can you repeat the question again? I miss your voice.
Sure. Can you hear me clearly?
Yeah, I can hear you now. Thank you.
Is it possible to use AI on fetus genes to predict the possibility?
Fetus gene, sorry, and what gene?
Is it possible to use AI on fetus genes, fetus, F-E-T-U-S, to predict the possibility of sickness in them before they are born?
I think using the genetic data, you can do, I think it's possible, when you have, I'm not sure about this type of the disease, but I think these days, having the genetic data, you can do the prediction for different type of the disease. Yeah, I think if you have the genetic data, I'm not sure about this type of the disease, but we are working in genetic data for different type of the disease and we get some promising results.
Okay. What companies have the best AI technology? Any that you are?
Depends what area do you want to work, but for example, Google, you can go to the Google Brain team and they have a very good AI technology. So I would say Google is one of the best one now in our area. And they are releasing some deep learning platform. For example, I don't know if some people here are familiar with TensorFlow, PyTorch, GRAS. So say Google. But there are other companies, if I want to say the top one is Google.
Okay, great. So just a reminder, if anyone else has any questions, type them into the chat. We have one coming in. If theory of mind is in your area, can you please explain about it?
Sorry, can you repeat again?
If theory of mind is in your area, could you explain about it?
Just miss your voice. I don't know, is a problem with my connection. Hello?
Let me type it to you. So just check your chat.
Okay. No, it's not in my area, Toria. Fine. No.
Okay. So I think that's about all the questions we have so far. Last chance for anyone that wants to ask anything, please go ahead and type them in. Otherwise, I think we'll be wrapping up the webinar for today. So I'll just give a few more moments to see if there's any other question coming in. I think that's it. I'd like to thank you, Dr. Jalali, for joining us today. The webinar, the lecture was very informative and helpful. And I'd like to thank all of you who participated and joined us on a Saturday. If you want to stay up to date on future lectures and webinars or upcoming events, we encourage you to visit aesa.org and you can subscribe to our mailing list. We do email all of our lectures and webinar links to our subscribers so that you can stay up. Become a member. Again, you can go to aesa.org to become a member. And on social media, we post all of our upcoming events there as well. So thank you for participating. And with that, we'll end the webinar. Have a great weekend, everyone.